This is identical to our paper cutting question that we did at the beginning. The only difference is we start off with a different size of paper. 30 centimeters long, 25 centimeters wide. So draw that 30 centimeters here, 25 centimeters here. Squares are cut out with a side length x, and then fold it up to make an open box. What is the volume of this box? Well, we have to figure out what this new length is here and what this new length is there, because if you fold along those lengths and fold up, you get a box with a height of x. So volume is length times width times height. Our length, which was 30, is now 30 minus 2x because of what we've cut out. Our width, which was 25, is now 25 minus 2x, and our height is going to be x. So this is a polynomial function that represents the volume. If we were going to graph this function, this is where the intercepts method is really helpful, because what do we know? We know it's already factored. If we make our volume equal to 0, we know that x could equal 15, x could equal 12.5, and x could equal 0. So if you did any of those cuts, you would have a volume of 0, which wouldn't be very helpful. But as far as graphing this goes, and sketching a graph is going to be really helpful for us later for figuring out what domain do we need to put into our graphing calculator. What do we know? We know we have an x-intercept at 0, at 12.5, and at 15. If we think of this function, it's going to make an x cubed function, because we have a negative 2x, another negative 2x, and an x. If you multiplied all of your x's together, can you see that you would get a positive 4x cubed? What is the end behavior of an x cubed graph? It's like a line, and this one's positive, so it would be going up. The multiplicity of all of our factors is 1, so when we graph this, we know it has to start down here and end up there. This is the graph of the entire function, but if we're thinking about our actual situation, we have to think about what is the domain that makes sense. And the only part that makes sense is this section in here. So our domain says that x has to be between 0 and 12.5. Otherwise, we don't have a volume at all. So then once we have this information, we can type this into our graphing calculator. And we have bracket 30 minus 2x, 25 minus 2x times x. And when we go to make our window, we now know that our x min, we don't need to go past 12.5, so I'm going to go up to 13. And as far as my x max, I'm going to go to my table right away because it's going up to 40,000. Notice how it started at 25, which is where I stopped at. And it's sometimes annoying because you're like, oh, how many times do I have to go up to get back to 0? If you want to do that quickly, you can go second, table set, and say, I'd like to start at 0 again, please. And then when you go to your table, it started at 0. So just looking between 0 and 10, looks like we've hit a maximum at around 5 at 1500. So when I go to my window, I don't need to go up to 40,000. 1,500 was the max. I want to go a little bit higher than that. Maybe I go 1,600, maybe I go 2,000. And now when I graph, I see that yellow part of the graph, which was important because that's the only part that really makes sense in this equation. And once I have that yellow part, I can go second, calculate. I want to find my maximum for left bound. All of these are going by 1, so 2 is definitely to the left of it. And it looks like 7 is to the right of it. Push enter again. There we go. Just drag your calculator screen to your notes. It's always easy to do, right? And we get the maximum happens at x equals 4.5 with a maximum volume of 1,512. So this question in the end had asked, to the nearest cubic centimeter, what is the max volume? So we can say max volume, 1,512 centimeters cubed. Make sure you include your units. What size of square should be cut? So answer all the questions. The size of the square is the x. The x here is 4.5. Does it say to the nearest centimeter? No, it says to the nearest tenth, so I'm going to write 4.5. And then it says find the dimensions. So our dimensions, well, the height was 4.5 centimeters by, if you do 25 minus 2x, which is 25 minus 9, 16 centimeters by 30 minus 2x, 21 centimeters. So then we get all of our dimensions for that box as well. Often find in these questions, either out of the textbook or on your quizzes and tests, when they ask things, they don't just ask for the maximum volume, they ask for a lot of the information. So make sure you read the question carefully in the end and work on these. So for tomorrow, I would like you to get the following questions done. 3, 4, 5, 6, 9, and 10. Some of them get a little creative in how they fold the boxes and how they cut things out, so they're not going to be all exactly like this.